Welcome. In this video we will demonstrate how to create a wind power plant in Simulink. For the model we will use the wind turbine induction generator pre-made block. It needs to be connected to a reactive power source as you can see from ports A, B and C. Of course it's a three-phase generator. Now we will create the reactive power source. First, we'll use the three-phase programmable voltage source to provide the three-phase power. It has the A, B, and C ports and the 0 for ground. We'll connect it to transformer, as it will be done in real life, because the voltage source uses a high voltage. We'll set it to 25 kilovolts. All parameters used in this model come from a pre-made model found in Simulink called a wind farm. We have converted all the values to a single wind turbine. The load flow generator is left as swing. Then now we'll put in the parameters for the transformer. The winding 2 should be set to YN, and we'll leave the saturable core as unchecked. The nominal power will be set to 4 megavolt amperes. And we'll set the winding 1 to 25,000 as per the voltage from the voltage source. And then we will transform this down to 575 volts, because this is what's used in the wind turbine induction generator. We leave the magnetization resistance as is and set the magnetization inductance to infinite. We could model this with a different values, but it's very relevant for the wind turbine itself. And all advanced settings are left as they are. Both the transformer and the voltage source needs to be connected to a ground. And the transformer ground needs to be connected through a resistor, so we'll set that up now. We're just using the resistor and setting the resistance to 66 ohms. And then simply using the ground block. The voltage source also needs to connect to ground. Finally, we add the capacitor. The capacitor can be used to create reactive power when connected to a voltage source. We're setting it to delta connection. And using a nominal phase-to-phase voltage of 575 as set up in the transformer. It shall not produce any active power, as this is of course left to the wind turbine. No inductive power, and create 4 megavolt amperes reactive of 400,000 volt amperes reactive. And finally we connect all the branches together. And then finally we connect the capacitor in parallel with the transformer. The reactive power source is now complete. We'll just put out the labels of all the voltages and the power levels to easier for later reference, basically. Now we'll set up the generator data in the wind turbine induction generator. We want this generator to provide 1.5 megawatts of power. By default it's set by 1.5 megawatts divided by 0.9, so just remove that and leave the other parameters as they are. We'll increase the base wind speed to 12. Because this is a common base wind speed, or used in many different wind power plants. Of course, these parameters can be changed easily later on to simulate different wind turbines. As you can see, at the maximum, at the base wind speed, we get a maximum power of 1 pu, or 1, which basically is the maximum value.
We will now construct the output stage of the model. From M, there will be several outputs, so we put a bus selector to choose which outputs we're gonna use. And if we double click here, we delete these default signals and select our P and Q, which is active and reactive power. And since the outputs are in PU, that's per unit, we need to put gains to get it back to actual power. So if we put the gain 1.5 million, we'll get back to watts. We then insert outputs so we can retrieve the values that's being put out by the model. We can rename them to P outs and Q out, so we later will find them easier. And then we connect the bus to the gain and to the outputs. And for this example, we will use a scope for the active power, so we will be able to study it in a graph, and a display for the reactive, so we'll just see the value on the screen. And we will now construct the inputs. On the wind turbine induction generator block, we have a trip, and that's basically a switch that determines if it's on or off. So we set an input here, so if the trip is 1, it will shut off the turbine. So then we set a second input for the wind speed, and both of these inputs are external, so they can be controlled from outside Simulink. Then we need to set up the power GUI. We set it to phaser type because the wind turbine works with phasers. We set the base power to 10 million volts amperes, and then we show it in volts and watts, and that's it. Now you could think that we can run the model, but we don't have an external input to the wind. So instead, for this example, we use a step that we configured to go from 1 to 12 meters per second, since 12 is our base wind speed. And now we're almost done. We just need to set the model configuration parameters. We switch to fixed step size and set it to something small, like 0.001, and let the simulation run for 30 seconds. So if we run the simulation now, we will see on the display the consumed reactive power, since it's negative. And if we open the scope for the active power, we see some strange lines, and that's because we don't display all the values. So we need to change in history and set no limits for data points, but we still don't have any values, so we need to run the simulation again. And now it's done, and we can see, if we zoom out, that we have some transients, and then we get a stable steady state value for the power.
As expected, the value of the signal is approximately 1.5 megawatts, which is the rated power for the wind turbine.